All right, thank you all so very much for allowing me the honor of coming and speaking here, especially being like the only guy who's going to intentionally open up Internet Explorer in this entire conference. But it's for a good cause. We've done a lot of neat stuff in Internet Explorer, and I think it's going to be good to show it all today. I think some of the impressions that some individuals may have are a bit dated. They're old, and hopefully we can remove some of those. So today, I'm going to be talking about mastering F12 in Internet Explorer. We actually don't have enough time to go through all of F12, so I had to pick just a few things that I guess would be more interesting to JavaScript developers. A bit about myself. I am Jonathan Sampson. I've been a web developer for 17 years, and today I'm a program manager on the Internet Explorer team. As I just said, I started there about 2 months ago, so someone at Microsoft told me you get about 6 months in before you die inside, and so I've got about 4 months of life left in me before I just turn cold, I guess. I started with this game. Does anyone know what this game is? Has anyone ever played this? This is the coolest. Okay, there's a lot of people in here. These are my people. This is the coolest game ever. So this game was released in 1997. It was kind of an open architecture. They had these files called cog files. And whenever you load up the game, it would first look for the CD. And if it could find the CD, it would load the cog files from the CD. But if it didn't find them there, it would first look in the file system. So you could create copies of these on your hard drive, open them up. They weren't compressed or anything. They were just plain text. And you could start to change the ways in which force powers and weapons in the game worked. And you could change references. For instance, there was a 3DO object called max.3do. It was this little rabbit in the game. And then there was like gun number 6, the repeater. And you could open up the cog file for the gun, and there was a bullet.3do reference. You could replace that with max.3do, restart the game, and then your gun is shooting rabbits out the side. It's really cool. And so this is what got me into development, the fact that we could rapidly iterate on things. We could change code and see the results immediately. And this is kind of what excites me about developer tools in general. I have a Twitter account called F12 Dev Tools, and there I basically share everything I learned from any set of developer tools in any browser. So that's what we're going to talk about today. IE got updated finally. It's like our annual update. It actually happens far more frequent than many people think. We update Internet Explorer like every few months at least. I'm curious, how many people knew that we actually update IE that frequent? 3 people, okay. And those are probably people that have to test in IE, so. Okay, so we actually update it far more frequently. Unless you're one of these people that like uncheck this button, never do that. Like friends do not let friends opt out of IE updates. We don't want to go back to the IE6 stuff. So since version 10, there's been this option to install new versions automatically, and we want to make sure that people always have that checked. So we're talking today about the updated developer tools. This tool right here is the UI responsiveness tool. It's really cool. We're going to cover this, I think, as the third one. But the overall tools themselves have been rebranded, rebuilt. They're actually built on JavaScript largely today, which is really cool. So it's nice to see Microsoft investing in JavaScript as a language. They've also done the same thing with Windows web applications or Windows Store applications or whatever they're called today. They change the name every now and then. But you can now build native applications in JavaScript as well. So we're going to talk about the different parts. Again, we don't have enough time to talk about all these, but we have the DOM Explorer, the console, debugger, network, UI responsiveness, which is what we just saw, the profiler, memory, and emulation, which the emulation is kind of confusing. It's not really emulation, but maybe we can get to that here shortly. There's actually more you can do. If we break this down just a bit more, there's quite a bit of other options and features in there. That's not scratching the surface. You could do quite a bit more. The third column I gave up. I didn't want to break it down any further, and so I figured I had better things to do with my time. And so we're going to go through a couple of these and just kind of check them out. The debugger is the first one. Debugger has all the common stuff you would expect to find in a debugger. You've got pretty print, so whenever you're loading a minified jQuery source file, you can actually expand that out and make it somewhat more legible. Super happy to say that we finally have support for source maps for everyone that likes to write CoffeeScript or even just likes to debug in an uncompressed version of jQuery. We have a source map designation. So if you run across a minified file, which happens if you're downloading jQuery from jQuery.com, there's not a source map comment in the bottom. And without that, the source map association is not automatically set up. So we can actually explicitly and manually do that in those cases. Just my code keeps us in our code and out of jQuery. I don't know how many people have ever tried to put a debugger or a breakpoint in their code and then step through and you wind up inside some weird bowels of jQuery place where it's like r.handle and you're not quite sure how many times you need to step forward to come back out into your code, and sometimes you'll skip your code and it's just a mess. So just my code will actually help us to jump past library code, stay inside of our code. We have a library and async frames. These are really cool too. So if you're actually observing the call stack, if you've frozen your execution in a particular place, you can actually look at the call stack and see if the place that you've arrived at was via an asynchronous function or via some library code in the case of jQuery. And then event breakpoints and trace points. These are just added actually August 12th. We just added these. Essentially, they allow you to modify all of the breakpoints and all of the correction. They let you modify all of your event listeners and all of your handlers globally without actually having to go and touch your code, which is really neat. And then finally, we have import and export, which are two things that I've wanted forever, and finally we have, which is nice. So if you're actually building, you record a session, you can send that to somebody else. You can actually debug somebody else's session, which I've had to do a few times inside Microsoft for other Microsoft developers. So let's actually take a look at these. Let's see, we're going to look at the debugger first. Let's see, that is fairly legible. What was that? I just got a scary blue screen, something I'm familiar with seeing. Okay. It didn't stick around, so that's okay. So okay, it's back. Is it because I'm touching the wire? Or because I'm running Windows? I don't know. Okay, so I have no idea what this is. What would Bieber do in this situation? That's an idea. Okay, so I'm going to look at just my code as the first thing here. I've got this little button set up, and this is neat. As the first guy on Windows, I can do this. And so I've got this button here, high contrast mode, and whenever I click that, it's going to switch everything around. And the way I'm doing this is I can actually show you the click handler over here. So basic stuff, we've got the body reference. There's the conventional $ in front of the body name to show that it's a jQuery object and the toggle class. And then I'm just logging out whether or not we have the class on there to see what state the body is in. And so if I were to open up the developer tools now, and let's see, we can check out the debugger here. Each one of these is accessible from a control, like this is control 3. So if you like to walk through code that way, I don't. I'm a finger type of person. And so we're going to check out the code here. So let's scroll down to here. So I'm going to set a breakpoint on line 45. And there we go. Okay, so now if I execute this code, it's going to actually freak out on me again, okay? Let's see, we're actually going to click on this button now. That's going to take us, it's going to freeze us on this line. Now you notice I've got this little blue icon up here. I don't know if there's a laser pointer or anything. I can actually use my mouse, I guess. There's this little blue icon which is already enabled, and this is debug all code or debug just my code. Obviously, jQuery is not my code. I have a couple commits in there somewhere, which is really nice. But jQuery doesn't need yet another weird person debugging their code. They have plenty of brilliant people doing that already. If this was not selected, if I weren't in just my code mode and I step forward using my little step keys, it's going to drop me right into this horrific place of nightmares and screams of baby horses and unicorns. And so we have ways to make this not as scary. I mean, pretty much every browser today has the pretty print feature so that you can expand this out. That's still not all that helpful. I mean, var c equals type of a. I don't really have any clue what that's referring to. And so if we wanted to, we could actually just skip all of the library code altogether. by enabling the Just My Code feature. So now if I enable that and I click high contrast mode, it's going to stop there again, but this time whenever I walk forward, it's going to recognize that jQuery is not my code, and it's going to jump straight to the next line that is my code. So I spend less time in jQuery's code and more time in my code, which is a very cool feature. The next thing, so we've actually just talked about the Just My Code. I want to actually show the source map designates, because you'll notice we tried to make jQuery a little more legible by turning on the pretty print, and that is helpful. It at least allows us to visually parse what code we're in and what it's doing. But in the newest IE developer tools, we can actually right-click on the resource here and go down and explicitly choose a source map. In this case, jQuery doesn't have the comment at the bottom. It's been stripped out for optimization purposes, I presume. And so now if I actually select that, we totally lose all of the minified, crazy-looking code, and we actually have the fully uncompressed jQuery code. So now if we do want to step through and actually see how jQuery does something, say how it cleans up markup if you're creating an element, then you can actually see how jQuery does that. It's actually much, much better. So that's source map and source map designation. There's this cool new feature that we kind of briefly talked about, event breakpoints and trace points. So all throughout my code, I've got event listeners. In this case here, I've actually bound one up through jQuery. So we've got the onChange event of the range element through the jQuery object. We're setting this timeout to issue the issue log function, which is going to log out value changed. We've got library code, asynchronous code, and our code all in this one little mix. And so one of the things we can do if we're actually inspecting that inside the call stack, let me clear out this here and drop a new one on line 51. And we're going to go in and change the value to invoke that. So if I drag this over, that'll stop. And now we actually notice that down here in the bottom right, where we are listing the call stack itself and showing what was the path of execution, we can actually see that there's a new collapsible area right here that actually issues or informs us that this is asynchronous code that fired this. And below that, you'll notice that we also have library code, which keeps, again, jQuery's code out of our way, keeps us in our code, makes us more effective. If you still want to see that stuff, you can uncheck here and actually see that the whole event started through r.handle, went through in.event_dispatch and up to the change handler and the async code and the issue log and all that good stuff. So those two items right there will keep the call stack a bit less noisy for us and allow us to really focus on the code that we're writing and not the code that we're running, which may not be our code. The next two things here, the event breakpoints and trace points, as we were talking about just momentarily, was the change event that we have here. I could go throughout my entire code base, find every place that I have a change event, and add a new console.log to actually find out like where these events are happening, access the arguments object, see maybe what's inside there. That would be kind of difficult. I'd have to go back throughout my source code and do a quick search to see everywhere where there's an add event listener change or anywhere I might have the jQuery syntax with the on change, or I might even have event delegation in place. It's quite a few things to actually search for. And so we've got breakpoints and trace points. Breakpoints will allow us to break on any event in any part of our code base. So if we came down to breakpoints here, I can close that and we'll add a brand new breakpoint right here. It's an event breakpoint. So this is different than the breakpoints we were just using where we're explicitly saying stop on line 53. This is an event based breakpoint. So anytime an event is detected, we can break on that. So we've actually got here, we've got collections of events. So if you're not quite sure which mouse event, if it's double click, mouse down, mouse move, anything like that, you can actually say, I want to break on any mouse event. You can do the same thing with keyboard events and pointer events. We've actually got inside here as well a change event. So now anytime my code issues a change event, as that bubbles up the DOM, we can actually freeze execution and inspect that. And so now if I were to come up here and change this again, you notice it stops execution and takes me exactly to my code, not into jQuery's code, to inform me that a change event has just taken place. This is pretty cool in my opinion, given I do nothing but debug websites all day. There's a fairly less invasive feature, which sometimes I may not actually want to stop the execution of the code. I may just want to know that it's taken place. And so the trace points is the feature that would be looking for assistance there. The cool thing about the change event too is we can actually add conditions. And so you get access to, if you think about the condition input here, this is actually like the body of your event handler. So you have access to the arguments object immediately inside there. You can base conditions off of the target that actually issued the event if you want to. You just put the text actually right inside there. You could say, arguments. It's a little bit difficult to type on here. Dot target if you wanted to. Grab the first argument, the event, which is usually the case. The trace points, let's see if we were to remove this. Trace points are similar, but they're less invasive, as I was just saying. So they'll actually just give us, I'll put in a string in here and say, change event detected. So in this case, we're actually going to be bringing up the console. And now as we change this, you notice that as the change event happens, it bubbles. We actually get a couple notifications here that change events have been detected. We can actually look into the object again, look into the arguments object, and pull out some information to give us more actionable information inside the console there. But this allows us to do this globally for all of our website, our entire web application, without having to touch a single line of code, which is really cool. I believe this pretty much wraps up what I'm going to be talking about on the debugger. The one that I'm really excited about, the very, very cool one, is the UI responsiveness. So if I blow past the debugger and the memory profiler and stuff, then you'll have to excuse me. But this is that is pretty much the changes that we've added to the debugger. I'm curious, how many people use developer tools on a daily basis, whether it's in Firefox or Chrome? And how many people use them in Firefox? Leave your hand up. That's actually like quite a bit. Looks like the majority. That's incredible. Okay. Does anybody watch Firefox nightly to see what they add to the developer tools? Couple people? It's like the most fun one to watch. Okay, let's see here. Again, I'm not saying which browser is my favorite. So we're going to go back here, and I'm going to jump back to the presentation here. So the next item we're going to look at is the memory. Memory, we get summary views. So if you're tracking kind of the lifespan of your application, we had a couple people that actually talked about long-lived single-page applications. I think one individual even talked about being prepared to have your page opened up for a year without being closed, which it sounds crazy, but we are approaching that reality. So we've got summary views, performance marks, snapshots, heap monitoring, tracking potential issues, issues like detached nodes, which are super common. Snapshot diffing, so this allows us to actually compare different states of time, our application, and see how it's changed as far as the objects and items held in memory. And then, of course, the import and export, which, again, is like one of my favorite features because it was very frustrating being able to debug a site but not being able to actually save that state out and send that to somebody else. So I'm going to jump into the memories tool here. This one is a little bit shorter, but they've got quite a bit more in the tool itself. So in this particular case, I've got a page that is set up to do some very terrible things. I've got an add image button, an images array itself. I'm going to close this. And after the images array, I've got a couple of event listeners, and you'll notice this one adds a couple images to the DOM, issues a couple performance marks. We'll actually look and see how those are rendered inside the summary itself. And then we have a button down here, which when clicked, we use that images array. We'll cycle over that, and any element that has a parent element will be removed from its parent element. And then we've got a couple items down here as well that actually will issue explicit performance marks to allow us to track particular events in the timeline of our application. So let me go ahead and actually run some of this. We'll look at what the tool itself looks like. So for the memory profiling, we're going to just start profiling. You can do that with keyboard or touching or anything like that. It gives us a real-time view into the memory used on our page. So you can see this page here is using 99.6 megs. There's nothing going on, really. It's always good to kind of let it go like this so you can establish a good baseline, understand what your website does at rest. We can grab a quick snapshot. You notice here I can actually see, we don't have any like epileptics in the audience, do we? Because this is, what in the world? If it's in the news tomorrow that Microsoft gives people seizures, this is going to be terrible for me.
You might try to to reduce your resolution.
Reduce the resolution?
That probably will fix it.
So I actually got quite a bit of profiling done here. I'm fairly confident that at rest my website is not doing anything too crazy. I can see that I've got about 1.03 megabytes of memory on this particular page at rest and about 1,109 objects. Gives me a neat little screenshot just to know kind of what the site looked like whenever I started performing this particular snapshot. So at this particular moment, what I want to do is identify potential issues, page leaks, memory leaks, that type of stuff. You notice there's actually one indicator right here, right up at the very top. There's this number 1, and they tell us that it's already identified a potential issue. So the developer tools are kind of proactively stepping out and saying, hey, we found something that you probably weren't intending on doing, something that could be potentially disastrous for you. If we click on that, we can actually see that we get, is this going to start freaking out on me again? Okay. Let's see here. So if we click on that, we actually get the types view, which will show us all the major constructor functions of the document itself, along with any indicator to the side of it if one of those constructor functions or one of those instances is causing one of the problems. And so you notice right next to function, there is that indicator again, and immediately inside there is in. I can hover over that, and I can see that in is actually jQuery 211. I'm curious if anybody knows what the problem is inside jQuery. Or does anyone know of problems inside jQuery, like just instantly? Nothing? So this isn't like a super big issue. But immediately inside jQuery is a series of tests. So if you ever looked at like $.support or something, jQuery actually perform a few feature tests to see if your browser supports a handset of features. And so if we look at the actual in reference here, which is the reference to the jQuery source, immediately inside there, the support, we can start to see that there's box size and reliable and pixel position, some of these functions that they use to detect support for particular features inside the browser. To do that, they have this detached node. They've created a div element, I believe, and they will apply some styles to that, read those back, and see if it was affected in the way that they would expect, assuming the browser supports those particular features. So already we have one item. None of that is actually anything I need to be concerned with. That's a jQuery issue, and it's actually not even a serious issue. It's just one detached node. It's not going to cause us any problems moving forward. But if I started doing some things that would cause us problems, like adding a bunch of images, you notice I just added, I don't know how many images, but you can see the memory spike there as soon as I did that. Now we're at 155.6 megs on the page. I would assume that if I were building a gallery or something like that, you can actually see the image here, that as soon as I remove these images from the DOM, garbage collection should come by and clean up, and the memory should be returned back to a fairly normal state. That's assuming I write great code. Again, I work at Microsoft. So we're going to hit a snapshot here. And so this will give us a new insight into where we're at. We can see the page memory has gone up by 1.25 megs, and we've added 12 new objects. You notice there's a slight discrepancy between the object count on the left and the object count on the right. Not every object being counted is one of ours. Sometimes these are objects that are instantiated by the browser itself. And so in this case, I can see that I've added a bunch of images. It went up 12. And now if I remove those images, I would expect that to go down. So if I delete all those images, essentially we just ran over that array that had references to all those, and we just plucked every single one of those out of the DOM, so they're no longer in there. I can start another snapshot, and I noticed that, well, there's no increase, but there's no decrease either. I have actually lost about 1.41K of data, but I still have 1,122 objects in memory. And this is the type of stuff that can really bring your website to a screeching halt, especially if you plan on having your tab opened up for a year. So this is the type of stuff we want to identify. And you'll notice actually now, instead of one potential issue, the browser warns me of 11 potential issues. And if I come into those, it'll actually start to show that, okay, now we actually have not only a function that was causing an issue, but now we have an HTML element, or something that is inheriting from the base HTML element type. If we want to go in and actually start to see more granularly what the differences are between snapshot 3 and snapshot 1, we actually have a compare feature that we have added for your convenience. This compare here, we can actually arbitrarily grab any one of these snapshots and compare it to any one of the others. It performs a diff, so if you're used to distributed version control, GitHub, this type of stuff, you can actually start to see the differences between files across commits. And so we notice here that we have an HTML image element, and we've got 10 of them. That's the diff between this snapshot and the first one. So this helps me to start identifying where those problem elements are, so that I can start to triage those. If we open this up, we can actually see all of the elements here. And at the bottom, to actually identify what is retaining a reference to these, we have the object references. And so I notice now I have item 0, item 1, and all of the other ones actually have this reference to images array, or images array has a reference to that particular item. So now my next step is to figure out, well, what is going on with images array? Is that something I actually want? I can see that there's actually 3 anonymous functions in the same scope as images array. If I wanted to, I can right-click on images array and show this in the roots view. And this will give me a nested hierarchy of where that reference is, so that I can start to figure out whether or not I want all of these things to be perpetually referenced by images array, or if I want to wipe out images array. And so it's not super easy to see, but let me see if I can zoom in real quick. So you start to see we've got the body container inside there. I'm using Bootstrap because I'm an awesome CSS person. And then immediately inside there, I've got a couple buttons, a click event handler on delete images, an anonymous function inside there, and then my reference to images array. And so I can start to use this information to figure out, okay, did I want this? Is this something I actually intended for the references to be long-lived like this? Or is this something that I did not intend to do? From here, any reference to a function inside our source code is actually going to be an active link that we can click on, which will drop us back into the debugger at that particular reference spot. So by clicking that, I'm now back inside my code, and I can see that images array for each, if node parent element, remove child node. That does everything for the DOM. It clears out the DOM, but it doesn't actually take the references away from images array. So in this particular case, I would need to reset images array, or do something else to make sure that I remove those references so that the garbage collection can come by and actually clean up or free up that additional memory. So in this case, if I were to come in to here and not the network tab, let's see if I can grab a different file. We are inside memory. Let's see, so I'm going to come down to about right here and do something super easy. We'll just take an easy approach to this. Images array, and we're going to reset that to an empty array. And we can jump back to the code, and I'll refresh this. Okay, so now as I start my memory profiling, I'm going to establish my baseline again, 115 megs. Once we have that, I can go ahead and add a bunch of images. I think tapping on that just tried to make it zoom in instead. Okay, so we'll add a bunch of images. That pushes our memory usage up to 174 megs. And we're going to take another snapshot. This will give us that difference between the first and the second. We see we added 14 objects in memory. That's about 1.5 megs. And now I will delete all of those and take another snapshot. So you notice now, actually taking this snapshot, we start to see the memory decline because we've actually reset the array. We've freed up all those references to those detached DOM nodes, and garbage collection can then come in and clean up after us. And we start to see that we had one object go up. I think that's the assignment of the array back to an empty array, and then one object, or 13 objects go down. And so we have a disproportionate net loss, which is actually what we're looking for. So in this particular case, the memory tool allows me to identify issues like that, there's circular references sometimes. You can actually find those inside the memory tool as well. We have, obviously, detached nodes is an important one because quite a few people like to build galleries and that type of stuff. And so this is definitely a very helpful feature. What is this weird thing on my screen? Okay. So this is definitely a very helpful feature for identifying those areas. And of course, you get your little screenshot thing if that does it for you. There's another item in here, though, that is actually super helpful because you notice as I'm adding images, I don't always know when those events are taking place. And I don't want to sit here and scrutinize bumps in my blue line. And so we've actually got support for performance marks that will actually come in through the timeline here and indicate what exactly you're looking at. So you can see that the add images performance mark was added 6 times. So I was clicking this button in rapid succession. And this is the actual code right here. So just by adding performance.mark and then some type of distinct label, we now have an indicator inside of our timeline of what event is taking place at that particular moment in time. Keeps us, again, from having to scrutinize the smaller details of the memory line here. So let's jump into the next item here. So that is memory. We tracked, I think, everything there. Obviously, the import and export. If we look at the memory tool itself, each one of these tools is going to have the old floppy disk icon, which is becoming less and less clear as to what that means to younger and younger generations. But we have the floppy disk icon to actually save it, and you've got the folder to open these up so you can pass these around and share them with friends if you need some help debugging a particular issue on your site. Next item is the UI responsiveness. So this is probably the coolest one just because I think it's the most aesthetically pleasing one to look at. Inside here, we've got the support for user marks as well. There's also some implicitly added application lifecycle marks. So when top-level events or big events like DOM content loaded or the load event or node removed events like that fire, you actually get implicit marks for things like that. We got performance measuring, so you can actually measure the time between a couple different marks you add. In this particular case, I was adding images of dogs, and then I'm removing images of dogs. We can actually measure the amount of time between those two particular moments. Visual throughput, so we can track frames per second. Event filtering, we can say specifically what types of events we want to be looking for, whether those are background events, network-related events, custom sorting, thresholds, so we can say if an event is less than 1 millisecond, we don't want to look at it, it's not significant enough, and we can filter out the noise and also the import and export, which again are 2 features that we didn't have in the past and were desperately needed. And so I'm very happy that we have those now. So let's close this out and jump to the UI responsiveness. I think this is probably the last one I'm going to show as well. So if there's quite a bit more you can do with the developer tools, especially in the console tab itself. There's a lot of new additions. But if you want to see any of that stuff, feel free to come and find me afterwards, and we can definitely talk about that. So inside the UI responsiveness, the first thing I want to actually show is this really cool set of keystrokes that add something totally neat that I had no idea this existed until Andy Sterling, the principal program manager of the F12 dev tool, showed this to me. If you hit Control-Shift-U, you actually get this performance dashboard on any page for the actual process of that thread. They'll show you the paint time. In this case, there's nothing being drawn to the screen, so there is no paint time. They'll show you the frames per second, the actual memory used by that particular tab. And this is something you can actually use to quickly diagnose performance issues on your pages. Each one of these, you can drill into them as well. So if we were to jump into the actual memory, we can sit and monitor the memory over time on any particular page as well from this small micro tool. Same thing with frames per second. If you're doing WebGL, something with animation, and you want to track the visual throughput, that will work as well. This was like probably the coolest thing. So whenever Andy showed this to me, I had one of those like major mind-blowing moments where you're like, I've not seen this before. It wasn't quite as magical as this guy's experience. There weren't fireworks and stuff, fortunately. So in this particular demo, there's quite a bit more code, but only because there's more things that you can track inside the UI responsiveness tool. So let's jump into that one here. The probably one complaint that I have about the developer tools is this vertical sidebar This is really, really annoying. But fortunately, we're having discussions internally about changing that UI up. So let's see, we're going to start profiling. So this actually doesn't give us an indicator of what it's doing. It just tells us that it's recording, and we can start to do a few things. So one thing I want to do is add this dog picture again. In this instance, after about 5 seconds or so, the dog image is removed on its own. I can then issue a couple performance marks. So there's 1, 2. And I can measure the events of how much time it takes to issue an XHR request. So I just retrieved 155 items from a remote JSON file. And then there's a list of the actual types of categories that we'll be tracking. So let's stop this session. That's going to analyze the data, happens fairly quickly, and we get the actual timeline of the full life cycle of the page. This is complete with every single paint event, every layout in the entire life cycle. So there's some really cool information you can get from this. How many people have never seen this before? I'm just curious. Okay, this is awesome. So this is really exciting. So you get a lot of really cool information. It's all color-coded, so obviously the purple is the rendering. Over here you see the spikes of blue. That's image decoding. So as the browser is decoding images, you can actually track that. It's very neat. There's a lot of cool stuff you can learn just by experimenting with this. For instance, if you have the same image that's loaded into a page twice, it's only decoded once unless you have a media query or a query string at the end. It was something I learned just last night playing with this. I was trying to drive the memory usage up in IE by loading the same image, but IE has some memory optimizations that would prevent that from happening. So by adding a query string, I was able to do that. So as we look through here, we've got tons and tons of paint events. This is really kind of more than we care to track. We can see that we start to have some style calculations about a quarter of the way through the page lifecycle itself. So those would be some inline CSS or some link references to external CSS files. We have a DOM event, a click handler there that we can actually see issued an HTTP request. So that would be our image. If we select that, we can actually see that where that request went, get some of the information about the status code, what the response was. The image itself is going to cause an adjustment to layout, and so we have style calculation again, as well as also the overstate of the button is going to issue style calculations. And then once we get a little bit down here, you can see that there's that timer that ran 5 seconds after I added the image. It tells me which method was called. Remove image, I believe, is the method. And if I click on that, it'll take me back to the developer, or the debugger itself, to debug that particular feature. Each one of these, I'm only showing the top level of this, but each one of these can be drilled down into them to see what types of things they invoked after they themselves were invoked. And so here's another click event. This would presumably be the performance mark. And so you can see actually that was the event listener there calls the add mark method. You can see the performance marks up here, these inverted orange triangles at the very top. So those are going to actually indicate when particular events were taking place in my application lifecycle. We've got another DOM event here, another click. And we can see that was the add mark again. So that was the second time I clicked it. Some additional styles. And you kind of get the idea of drilling down through that. We've got as well filtering. So we can actually reduce the amount of noise if we're not interested in UI stuff. For instance, if we're trying to track network activity, we can toggle the UI stuff off, and now all of a sudden we know that we had a request, I have my XHR being measured, and there was a second request for the features.json. The XHR thing is pretty cool, so if we were to actually right-click on that, you notice that it's actually really small. It's 28.82 milliseconds in size. If we wanted to focus on just that event, we can actually filter to that event, and I start to see of the components that I have rendered, which I've turned off UI, but of the stuff that I have rendered, this is the full life cycle of that particular request. I'll show you real quick the code that we have that runs that. And so here is the add event listener for the click event. At the very start, we do performance.mark, XHR sent. Once we get the response back from jQuery's getJSON method, we actually issue performance mark, XHR returned. And then at the very bottom of that, after we have both of those references, we can then issue the XHR flight time measurement, which is going to give us those black bars to show us exactly how long that particular event took. So in this case, if we wanted to, we could turn those, this information all back on and see the full anatomy of that XHR request, what it started and what followed as a result. So you can see that once we get the data back, we issue the load event to inform the user if they want to subscribe to that event, the data has been retrieved. So it's looking like we're running out of time, but again, if anyone wants to talk more about the developer tools, there's quite a bit of stuff that I actually haven't been able to show. Some of the other events and information that you'll see inside here are media query listeners and such. So if I were to, let's see, I'll dock this again. I'm going to zoom back out. If I had a media query listener, for instance, on this page, I'm doing some really bad responsive design. So I've got this media query in there that's listening for whether or not the window itself is a minimum width of X. And if it is, I actually add this class to the body. And so if I were to resize this particular window, you notice I go into like full Netscape mode with blinking stars and stuff in the background. In this particular case, I have a media query listener that's doing that, and so we'll actually see if we're recording the information in UI responsiveness that a media query listener itself was fired, and it's caused us to actually issue new style calculations, new layout, and that type of stuff. This is, again, just kind of scratching the surface of everything that we've added inside the developer tools. There's a whole bunch more that I would love to show anybody, but I certainly appreciate you guys' time, and find me later if you want to talk about it. That's all.